But we'll get into areas of trapezoids first. So I first have a review of how a trapezoid is defined. Picture of a trapezoid off to the side. So remember, a trapezoid is a quadrilateral with, and it has two parallel sides, which are called the bases. And that's kind of already labeled off to the side there for you. So the two sides that are parallel to each other, or you can think of it as one pair of parallel sides, those are each called a base. And then we have here the height is the perpendicular distance between the two bases. You can see that's labeled in that diagram as well. It must be perpendicular, just like the height for parallelograms and the height for triangles have to be that perpendicular distance. So that is key. And then to explain why the area formula for a trapezoid is what it is. So this picture is showing if you put two identical trapezoids together. So you have one trapezoid and then it's kind of rotated so that you create a parallelogram. And if we then use our parallelogram formula from yesterday, the area was base times height. So our base ends up being the b sub 2 and the b sub 1 added together. So I can call that b sub 1 plus b sub 2. And then our height, which is already drawn in, that perpendicular distance is h. So the area of the parallelogram is the b sub 1 plus b sub 2, all of that times h. And then you can see from the picture, the area of a trapezoid is exactly half of that. So that's two trapezoids together, so taking half of that gets you the area of a trapezoid. So area of a trapezoid, the formula is, or two ways you can write it, is 1/2 multiplied by this base here, b sub 1 plus b sub 2, times the height, which is h. But you can also write that as b sub 1 plus b sub 2 times h, all divided by 2. If that's more helpful to you than seeing the 1/2 in front. So you add the two bases together, multiply that sum by the height, which has to be perpendicular, and then divide that by 2. All right, so we just have a few problems that deal with finding areas of trapezoids here. So the first one, it says the purse is in the shape of a trapezoid, roughly. How much material is needed to make the side of the purse showing? So how much material? Material is what's on the surface. So area is what this is looking for. Problem solving mixed into this. We already have labeled for this purse. We have one base is 28 centimeters, the other is 58. And very nicely, we already have the height also, which is 30. So I can set this up. The area is my two bases added together, so 28 plus 58, all of that multiplied by 30, and then divided by 2. And then here you just have to be careful how you type it in your calculator. You have to make sure that with the adding the 28 plus 58, you do that first, so that's 86. I then multiply that by 30, and then I divide by 2. So it should be 1,290 would be the area. And then it's measured in centimeters, so centimeters squared. So 1,290 square centimeters of material would be needed. Okay, questions there? Otherwise, go ahead. I don't think I'll walk around because it'll probably be quick, but go ahead and answer number 2, and then you can at least check it. You can look at number 3 also, but I'm going to talk about number 3 with you. But if you want to look ahead and try it. Okay, I'm going to show the answer for number 2 so you can check. Like I said, we'll talk about number 3. And if you're starting it, just make sure that you're making sure that you have things written down correctly. So 2 gave you both bases, gave you the height just using the formula. 2,983 inches squared is what you should have. Any questions on that one? Okay, then for 3, so it says, what is the area of one earring that is in the shape of an isosceles trapezoid? So in looking at this, we have our 2 bases. One is 2 centimeters, one is 4 centimeters. The 3 centimeters that here is the length of this side of the trapezoid. It is not the height. It is not perpendicular. So the height, if you were to draw in the height would actually be, I didn't draw that very straight, but this would actually be the height, that perpendicular distance. We have to find that. It is not 3. So I'm going to I'll call that h. That's my height. Now, because this is an isosceles trapezoid, first of all, what does that mean if it's an isosceles trapezoid? Each one. The 2 sides are congruent. So if this side is 3, Ashley, are you right back there? Ashley? If it's an issue, then I'm going to have you sit up here. Okay. So these sides would both be 3. So I actually could draw down a height on this side also. And you can see then that this distance in between those 2 heights that I just drew would have to be the same distance as this base up here. So this distance here would be 2. And because it's isosceles, these 2 right triangles that I drew in, you can actually argue because they both have one of their legs is going to be the same height, and then they both are right triangles. So by hypotenuse leg, they are congruent triangles. So that means that these lengths should also be the same. And if the entire base here is 4 and this is 2, these must both be 1. So how that's helpful is I end up with a right triangle. I'm just going to draw the right triangle because I have a lot written there. So I had the 3 here. I'm trying to find my height, and I know this is 1. But that then allows me to use Pythagorean theorem to get my height. So I have to find the height first. So I would have h squared plus 1 squared should equal 3 squared since that's the hypotenuse. So that would be h squared plus 1 squared is 1 equals 3 squared is 9. And then I would subtract 1. So h squared is 8. And then take the square root. And for right now, I'm going to give my answer as a decimal. I'm going to leave this, though, as the square root of 8, just to do less rounding in the middle of a problem. So I'm just going to leave it for right now. If you wrote 2 point, I think it's 2.8 approximately, I think. But if you wrote that, that's fine. I'm going to leave it as square root of 8, and then I'll round my answer at the end. So I now have my height, and my 2 bases, again, were 2 and 4. So my area then is my 2 bases added together, 2 plus 4, multiplied by my height, which is the square root of 8, and then divided by 2. And I can just type that in. I do know 2 plus 4. I don't have to type that in. I know that's 6. So then I have 6 times the square root of 8, enter, divided by 2, enter, and then if I round to 1 decimal place, I'll get 8.5 approximately. So for some of these problems, I know it's difficult, that'd be centimeters squared. I know it might be difficult to not round in the middle of a problem. It's better if you don't round anything until the end, or it gives you more of an exact answer or a better approximation, I should say. Any questions right now? Area of a trapezoid. Okay, so like we did yesterday, you might have Pythagorean theorem to find the height, and then you have your formula that you just have to keep track of. Then next we have rhombus and kite. So I wanted to review their definitions with you. So a rhombus, remember, is a parallelogram. So it's not just a quadrilateral, it is considered a parallelogram because you have two opposite sides that are parallel, and that's with all four sides congruent. So this first picture here is a rhombus. Since it is a parallelogram, that does mean that you can find the area of a rhombus using the area of a parallelogram formula. But you might be given different information. So there is a specific rhombus area formula. And then a kite is a quadrilateral. So four sides, and it has exactly two pairs of consecutive congruent sides. So remember with a kite, again, there's a picture over here of a kite. So it's not opposite sides that are congruent, it's the two pairs of sides that are consecutive to each other would be congruent to each other. So the area of a rhombus and a kite, that area formula is actually the same. So it is 1/2 times d sub 1 times d sub 2, or we can write that as d sub 1 times d sub 2 all divided by 2. And this is where d sub 1 and d sub 2 are the lengths of the two diagonals. So it shows here this is a rhombus, and it shows you have one diagonal is d sub 1, one is d sub 2, same for a kite. Remember with both a rhombus and a kite, the diagonals are perpendicular to each other, so you may have Pythagorean theorem involved to find certain measurements because you do have that intersection as a right angle. So if we look at 3A, we'll look at first. So in this picture, and we have some congruency markings, I know that just this half is 6, meaning I know this half is also 6. And then just this half is 7, so this half is also 7. So if I'm finding the area, I'm taking each full diagonal, multiplying them together and dividing by 2. So one of my diagonals is 6 plus 6, so it's 12. And the other diagonal is 7 plus 7, so 14. So 12 times 14, and then divided by 2. So 12 times 14 divided by 2 is 84. So that would be the area for 3A. And then 3B is really nice. 3B just gives you the full length of each diagonal. So sometimes they are, the measurements are given outside of the shape. So just making sure you know what you have. So for that one, we can just go straight forward and just multiply 16 by 9 and divide by 2. And that would get you 72 square inches. But then 3C is just a little bit different. So any questions on those two? It's basically for a rhombus or a kite, you have to be able to find the lengths of the diagonals to use that formula. So 3C says what's the area of the kite shown? The 6 inches that's given is this kind of bolded segment, so it's part of that longer diagonal, but it's only part of it. In a rhombus, actually, let me label this up here, just some things to remember. When you have a rhombus, maybe I should do it up here. So the diagonals, not only are they perpendicular, perpendicular for a rhombus, but the diagonals of a rhombus bisect each other. So that's like 3A that we just did. That's a rhombus where these would be congruent to each other, and then these are congruent. So for a rhombus, you have bisected diagonals that are also perpendicular. In a kite, that is not true. In a kite, you have perpendicular diagonals. Actually, this shorter one that I drew, this one is bisected. So these two are congruent to each other. And again, that would be, it's because of the hypotenuse leg, because you have a right triangle. Both of these triangles share this leg, and then they're both right triangles. So hypotenuse leg, they're congruent triangles, meaning those sides are congruent. But this other diagonal is not bisected, just to keep that straight. So when I look at 3C, if this is 6, that does not make this 6, and I know it doesn't look like they're the same, but just so you understand that. These two, though, for this other diagonal, these two would be the same. But we don't know either of those. So we have a couple of things to find. I'm going to start, I'll draw on a 90-degree angle here. If I call, let's say both of these, if I call those X, I'm just going to label one of them. So I can find, or I can use Pythagorean theorem to find this shorter segment. My right triangle has a leg of 6. The other leg I don't know, hypotenuse is 10. So I would have 6 squared plus x squared equals 10 squared. So that would be 36 plus x squared equals 100. Subtract 36. So x squared is 64. And then take the square root. So x is 8. So I know these segments are both 8, meaning that diagonal is 16. And then I need the other diagonal. I know part of it is 6, the other part I don't know, but that actually gives me another right triangle, this one here, which if I call this length, I'll call it y, just so it's something different. I now know this is 8, my hypotenuse is 17, and I need this leg. So I would have y squared plus 8 squared equals 17 squared. So y squared plus 64 equals 17 squared is 289. And then I would subtract 64, which is 225, and take the square root, which is 15. So y is 15. So I have one diagonal is 8 plus 8, which is 16. The other is 6 plus 15, which is 21. So then for my area, I would do the diagonal of 16 multiplied by the diagonal of 21 and divide by 2. So 16 times 21 divided by 2 gets you 168, and that's inches squared. Okay, so as I mentioned, you might have Pythagorean theorem in there. You might have it multiple times like this one. It just kind of depends. So part of your assignment is going to be just to recognize what shape you have, which might sound silly, but if you can't recognize what shape you have correctly, you're not going to use the right formula.